Hello everyone, welcome to again to another tutorial session by Eric. Eric is a, excuse me. So today Eric will be talking about building LLM agent made simple. So it's a very interesting tutorial session. And Eric, he's a senior principal data scientist at Modena. He leads the data science and research team to accelerate science to speed up the medical development. So you pay kind of keen attention, and if there's anything that you need, maybe questions, you can it's an interactive session. So yep. All right. So let's start the session. Thank you.
Thanks a lot. Thank you very much, Radim. Okay, thanks everybody for coming. How are we doing with the audio? All good? Cool, sounds good. Thanks everyone for coming. It's my pleasure to come here and share how to build LLM agents and done in a slightly more simpler fashion. My goal for the tutorial is to have everybody leave with a mental framework more so than anything else, tools are tools. But the way you think about agents is actually more important, and that's a thing that has borne out true, shown to be true in application after application after application that I've seen being developed at work and from hearing other stories as well. So before we go on, and before I continue blabbering, I'm going to have everybody try to get set up, because the setup is a few clicks with no command line instructions. Nothing runs locally. So I took a lesson from my friend Ari, who brought a laptop at another conference that couldn't install absolutely anything. And so for today's tutorial, I have decided we are going to run everything in the cloud as much as possible. So I would like to have everybody run through the instructions. Once again, for those who have run through the instructions at the tables, could you just raise your hands, please? All right, these are the people you can, who have graciously agreed to be a resource person for someone else. Right, they are a resource for my MCP server. If you need any help with any of these things, with respect to installation, please look to them. Meanwhile, I'm going to just quickly run through the instructions first, just so that everybody can see what's supposed to happen. So first off, if you go to the PyData conference schedule page, and then you click on the tutorial session, you'll notice there is a link down here, and it goes to my username, LlamaBot, and then some tutorial folder underneath. We open up the link there, and you'll notice there is a green shield button over there called Open in MoLab. And if you could just click on that, the source code for today's tutorial notebook will show up. Once you're done with that, click Run in MoLab. Now in my case, I'm already signed into MoLab, so it'll jump straight to there. And I'll just do that right now. For some of you who may not have heard of what MoLab is, it's like Google Colab, but for Marimo notebooks. The entire suite of this entire tutorial is going to be run inside a Marimo notebook. I'm a fan of Marimo. They're not sponsoring my presence here. So this is from the bottom of my heart. I do love what the Marimo project has been doing, what the developers of Marimo have been doing, and so I decided to write the tutorial in a Marimo notebook. MoLab is Colab for Marimo. In your case, you wouldn't necessarily jump straight to here. You might have a pop-up that asks you to sign up for MoLab. Go ahead, sign up. It's free. There's two one-click options. One is through GitHub. One is through Google. Go through the authentication process. You will then possibly go to that page where you're asked to run in MoLab. And the first time around, you're going to get possibly an error. That's I've seen play out over multiple times for different people. What you do is you just go back to this page again, and you click on Open in MoLab one more time. Just walk through the whole flow. That's the simplest way to solve the problem. And then the second time around, you should have no issues. Once you're inside the notebook, the first thing that I want you to do is to actually click the bottom right-hand button, which is the play button down here. That will kickstart the installation process for any other dependencies that couldn't be specified directly. So you'll notice it's asking me to install LlamaBot and PDF to image, as well as installing Poplar utils through some Python code. I'm going to hit install, and that will do the trick. Okay, so I'm just going to have everybody walk through that. while then now I finally go and introduce myself a little bit more. So I just wanted to kickstart this in the background because I know it may take a little bit of time, all right? So yes, my name is Eric. I work at Moderna. Well, by day I work at Moderna. By night I hobby code all sorts of stuff in the open source world. LlamaBot is one of them. There are a few other projects that I've been involved with. I got my start in the open source world through the Matplotlib project, and it was a wonderful journey back in 2015. I'm always grateful to the Matplotlib devs for coaching me through a lot of what I know for software development back in 2015 at a SciPy conference sprint. And so those were great days. All right, if you're curious to know a little bit more about me, I maintain my own website. Its URL is that, ericmjl.github.io, or you can just search for my name on Google, or search my name plus Moderna. There are multiple people who have the same name as I do. And then you should come to this somewhat nerdy-looking website. Yeah, so I'm at Moderna. I used to work at Nyber. I'm always doing my personal, professional mission in life is how can we make science run at the speed of thought? Because if we can make science run at the speed of thought, we can discover medicines at the speed of thought, and then more people can be spared the suffering of whatever diseases that they might be going through. Yeah, so that's a little bit about myself. And LLMs, for me, represent another step on that journey to making science run at the speed of thought. There are things that LLMs can do much faster than what humans would be able to do. And so back in, I think it was 2023, when LLMs really started becoming hot and there were APIs being developed for LLMs, or being released, sorry, for LLMs, LM Access, I started developing the project LlamaBot, which is what you'll be using today. Unlike LangChain, maybe other AI SDK, et cetera, which have a huge community, this one for me represents a teaching tool and a thought tool. So I build stuff to help me think clearly about a particular topic. And so LlamaBot represents that. It's been, as a result of my understanding about the LLM world changing over time, it's actually been rewritten 3 or 4 times in its entirety over the intervening 2 years. But I do maintain it as open source software, so in case anybody chooses to use it, it's available for you to use. I do want to put fair warning. It evolves pretty drastically at times because of different ways in how I'm thinking. So just watch out for the release notes. They are all AI-generated release notes, and they are AI-generated release notes based on the diff that describe exactly what was changed. I've made it fully automated, so I don't have to write any release notes. But pay attention to the release notes, because that will help you understand what's changed, what's breaking, what's not. OK, cool. So quick show of hands. How many of you have successfully set up the notebook like it's running, and you should only see one error in the notebook? The only error should come from a file not being present, and that's by design. So sorry, I just wanted to double check again. How many people have it running? OK, so for those of you who don't yet have things running, please go and ping a neighbor who has successfully run the setup instructions. And then while you all are doing that, I'm going to introduce a little bit of today's tutorial so that we can just let people catch up as well. So today's tutorial is basically about how to build LLM agents, and maybe a little bit by extension, how to build LLM workflows. How many of you are aware of what the difference between the two are? Sebastian. Oh, wait, sorry. For the recording audio.
I guess the answer will depend a bit on how you exactly define it, because different people have different ideas. But
Yes.
the way I would understand it is that an agent is an LLM that can call tools, whereas a workflow is a sequence of multiple agents that get called in sequence.
Yep, OK, that's a good definition. I like that. Anyone else? Any other volunteers? I thought I saw another hand over here. OK, the AI enthusiasts seem to be at this table.
So my view is like Agents are like more open-ended, so that's like what you like a Claude or Claude Code. You just basically have a conversation.
Yeah.
And the workflows, it's very focused. I mean, I built a lot of those. It's
Yep.
something that reads your Gmail, sees with invoices, like
Yep.
tracks the packages. So that would be workflow.
Yep. Okay. And I think back there we had one more.
I think it was
Same
the same
thing.
thing, autonomous versus mode defined.
Yeah. Okay. I think that's a good working definition. You would call workflows, LLM-powered workflows, any computer program that you write that involves an LLM call in the middle that isn't involved in either forking and branching of the logic, or, as Sebastian mentioned, isn't involved in some kind of autonomous decision-making to call on a separate tool that then returns back. Yes.
I guess, reassessed my understanding. So would workflows be something, so agent is like the user goes and initiates the conversation and talks, right? And workflows, it just sits there and it could be triggered by some external events and
Yep.
it goes to user and maybe multiple users and
I
says
think
like, do that.
interactivity is definitely part of the equation as well. So some people may argue that agents are a thing that involves interaction with users, and I'm very careful of that definition because agents are not necessarily chatbots. You can have interactions with users that are not chat mediated. Think about email agents, email-based agents, just as a the simplest analogy for what you might think, right? It's not a chatbot, but it is something that you can interact with, okay? Okay, so when it comes to today's tutorial, we're actually going to build a hybrid. Based on that definition, we're going to be building three things. We're actually going to be building out two workflows, and then orchestrating those workflows with an agent. And of course, everybody builds a chatbot. So just to make things a little bit more accessible, we're going to implement this agent as a chatbot, but you should know that there are other ways to do this. And I've chosen to do it as a receipt processor and invoice writer as the example, just to make it really accessible, right? Like if I were to choose something from the sciences, I would lose half the crowd immediately. So let's do something accessible. Let's work with receipts and invoices. One is extraction of data from receipts, and then the other is generating a document. Those are, what we're gonna have here are like very minimal implementations of those ideas, but those actually represent like what I've seen to be 70 to 80% of the value that you can get from an LLM. Cool, so as I have mentioned also, this entire tutorial is written inside a Marimo notebook. The way that you know that the Marimo notebook is running correctly is you've hit the play button on the bottom right-hand side and it's run from top to bottom and you've only got one error, right? And if you scroll all the way to the bottom, you'll see some of the outputs already there, but don't worry, I've taken advantage of the reactivity and figured out a way to get people coding in this room as well. So you're not just gonna listen to me blabber for an hour and a half. That would be way too boring. Okay, final thing before we go on, you may be wondering also, like, how the heck am I gonna access an LLM? Because as I've learned from the past year and a half, 2 years of teaching LLM tutorials, access to an LLM is the hardest thing ever. You can choose to do it locally, or in my case, what I've done is I've just so happened to have $500 in modal credits, and so I hosted Ollama up there. Everybody will be able to access that thing. Please help me burn down the $500, all right? So that is how you're gonna access a wide variety of Ollama hosted modal models. It's not the most pretty implementation. It's way overpowered. Like I have a H100 hosting Gemma 3N, but don't do that, okay? Like Gemma 3N is 3 billion parameters. H100s have 80 gigabytes of RAM. The disconnect there is too huge. I'm gonna make that on Wednesday. The talk that I will do possibly will be live improving that endpoint with AI-assisted coding in front of everybody. So we'll see whether that works, okay? Meanwhile, just know that that's how we're gonna access LLMs. While I still have the $500 or more than $0 of credits, you're free to use it. But once I hit 0, I'm gonna shut down that endpoint, right? Because I don't have a credit card attached to that modal account. All right, are we good with respect to the tutorial notebooks? Can I just double check and confirm. Yes.
For whatever reason, I'm getting a lot of errors at package not found. I don't know. Maybe I'm installing it, but
Me too, for what it's worth.
Yeah.
what did you
option to
expect
start
that it will
installing,
be pre-installed or?
If the package is not found, you should
Yeah, I
have
do get like a.
the installation pop-up shows up as well, and it's still showing errors. Is that right?
And it works.
Then it
No,
worked.
it works.
Then it worked. Okay, yes, that's also expected. So can I just double check now? I hope to see 80% of the room good to go. Yes, we're about there. Any other final lingering issues?
No, you said that. Oh, sorry, you were first.
I have 4 errors that are related to the.
Receipt not found?
Yeah.
Yep, that in my brain
That's
is one
also
error.
one.
Yeah,
Okay,
okay, cool. Any others? Okay, great. I think we're off to a great start. So, when it comes to building LLM-powered applications, let's start with part 1. When it comes to building LLM-powered applications, first thing you want to do is you want to actually treat it like traditional automation at first, right? You do not want to go in thinking, I'm going to build a chatbot. No. First thing you want to do is you want to really go and isolate what are the workflows that you want automated. And this, by the way, came from an awesome, this idea finally percolated for me from an awesome conversation I had with Sebastian at a PyData Boston meetup. So he's an awesome guy. You should go talk with him. And he'll give you a lot of hot takes on LinkedIn that are great, that are also very insightful about the AI world. But it percolated that, yeah, you want to start by thinking of what is the repeatable workflow that you do manually over and over that might have the potential to be automated. If we think about receipt processing, it's a data entry problem. I have a receipt, I need to insert it into a table. So what can I do to help automate it? Well, I might start with traditional OCR, and then I might need to do some receipts have all sorts of shapes and sizes. I might need to identify where my receipt needs to be processed in a certain way. I might have certain categories of code for different vendors and stuff like that. That's if you think about it from a traditional automation perspective. Now, for a subset of workflows, though, you can add in the use of an LLM at a very tasteful juncture, at a very specific point where you need to do something that traditional code can't really do. And that's where LLMs can help. So we know that vision language models have the capability to take take images in and output text. And then LLMs also have what we call structured generation, which enables to take free text in and output structured text. So imagine now we've got a VLM-enabled workflow that enables me to parse the text that's present, followed by followed by an LLM-powered workflow that lets me do structuring it according to a schema that I predefine. That's actually part of what we're going to do in today's tutorial. So really what we want to do is we want to start by mapping out the workflow. Now, there's always going to be a bajillion and one ways to solve every problem. Sometimes there are 2 or 3 more obvious solutions, and I'm going to just stick to the VLM plus LLM solution for this particular tutorial. However, you should know that I'm not an LLM maximalist, and I do not advocate for everyone to be an LLM or VLM maximalist either. Think what you can solve with traditional code first, and then if you can't solve it with traditional code, do it with an LLM or a VLM. So that's the part for receipt extraction, data extraction. And then there's a part for, say, generating an invoice, right? You might need to, which is an example of just form filling as well. And so those are 2 workflows that are, say, manual in the life cycle of a business of some kind that could benefit from just a little bit more automation, and we're going to show how to do this with LLMs and VLMs. Here we go. Let me scroll down a little bit to here. So if you think about then how you would integrate such a workflow, right, into your broader set of systems, it's one thing to say I got a PDF and I extracted this Python object. But it being a Python object in memory is not particularly useful until you've got APIs that let you schlep it out into a database, for example, right? So you can store that information and keep a continuous record over time. Or unless you've had additional systems that like pull from databases. Now, because of the nature of this being a very fast-paced 1.5 hour long tutorial, I'm not going to touch on that, but I do want to make sure you all are aware that you need to think about these other parts of the problem as well. Before you go in saying, hey, I'm going to build an LLM or VLM-based solution, think about the full life cycle of like what needs to happen with your data. You need to pull it from a source. Make sure you have access to that source. You need to store it in some destination. Make sure you have access to that destination, write access, and that sort of thing. Okay? All right. Let's start with the receipt processor agent. So what we're going to do is a two-step thing, as I just described. We do an OCR step, and we're going to use DeepSeek OCR that is hosted on the Ollama endpoint that I've got for everybody. And then we're going to do a structuring step, which is using structure generation, take the output of OCR and turn it into a pydantic model object or something like that. So I'd like everybody to scroll down a little bit. The first part is what we have. The implementation, as you can see in LlamaBot, is you have like LlamaBot simple bots, or you have for simple just vanilla text generation, or you have structured bot. If you scroll down a little bit more, paired with a pydantic base model object for creation of structured data models. And so what I'm going to have everybody do as part of the exercise here is, if you look at the description up here, I would like you to define the receipt data schema. And in a moment, you will actually take a receipt that an actual one of my receipts, and try to process it with this bot that you've helped to create. And so the part that I would like you to do here is to fill in this piece over here. I'd like you to fill in this piece over here. I have defined already one field that is needed for this bot to succeed in what it's supposed to do. I would like you to fill it out with the rest of the things that we've listed up here: date, amount, category, description. And so go ahead and do that. We'll give about 5 minutes or so. Make sure you're typing on your keyboard. And if you are genuinely feeling lazy, if you scroll all the way down to the bottom, there's the answers right there. I'm not going to stop anybody from typing speeds. I'm not going to let anybody's typing speed stop you from completing the tutorial. Meanwhile, though, I will type it out live for everybody. To English.
The ellipsis mean automatic?
The ellipsis means it is a required field. I think that is one little bug or error that might be present inside your notebook. So please change what was here originally was str. Please change that to ellipsis, triple dots.
All of us.
Separate, like, nullable parameters or something?
Sorry, all of us should make it ellipses?
Yes.
Okay, thank you.
Yes. Please make them all ellipses.
Interesting. Because I've used them before. Tuples of varying lengths. That's the other thing.
It's that one is normal type annotation. If you have a tuple in your string, comma, dot, 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 it means it's a list of strings.
Okay.
Eric, why are the descriptions important? Are they going to play the role for LLM, to help LLM, or just for?
Yes.
Okay.
Yes. Thank you for asking. So why
a lot
do
of
we
time.
have this description here? Well, it turns out when you use structured generation, if you have a pydantic model, and you compile that to just regular JSON string, the description field is also passed in as part of the context that the LLM receives. And so if you write a good description field, it's actually documentation. One, it's documentation for yourself as a human being. Two, it is also documentation for an LLM to do the right thing, or to increase the odds that it's doing the right thing. Okay? What did I miss? Building field info. Well, okay, let me cheat. Actually, turns out in the answers there's no fields. Whoops. Should have caught that. Well, okay, you're allowed to cheat then, if you'd like to. Let me come back here. I'll just take out. I'll do that, but I might just be missing what the syntax actually is for fields. So I'm going to take that out for a moment. But do know that if you do put the description present, it'll help things as well. Oh, I see what the issue is. I'm going to change date to stir for the time being, but you should know that you can put actual dates in ISO 8601 format, YYYY, and then DD. Please do not write dates in any other format than ISO 8601. Thank you. Thank you for coming to my TED Talk. Okay. And if you would like to try out, check that the pydantic model was generated correctly, I would like to invite you to try to do this. Dummy receipt is equal to receipt data exercise, and we'll fill it in. Vendor is equal to PyData. Date is equal to 0251208. You'll notice a weakness over here, and because we're not using date objects, it is possible for me to enter something invalid for the date. So if you can actually stick with actual pydantic and Python types, that's to your advantage. We'll do amount, $2,000, category is equal to food, and description equals lunch. And if I do dummy, pardon me?
That's an expensive lunch.
That is a very expensive lunch. And if I were to do that,
Should be without currency symbol.
Yes, that's right. It's supposed to be afloat.
Oh, you forgot the field of how many people.
Jeez. There we go. So if I did that, if I created dummy receipt and then evaluated dummy receipt right at the end, you should see something that looks like this. You all see that? Yes, Ben?
Yeah, is that like just Marimo does that display for financial?
Yes. So I vibe coded the HTML display for the receipt data object, and you'll notice right at the bottom, I have defined over here underscore repr HTML, and that is a protocol that's attached to Python objects that both Jupyter notebooks and Marimo notebooks will respect. So if you have an HTML object, HTML that is embedded inside, that is returned, an HTML string that is returned by repr HTML, it will display. And so you should see wonky connection. You should see the objects that you see on your screens, basically. This like green view, et cetera, et cetera. All right? Are we all cool with that? So what you just implemented was a pydantic model that represents the schema for what you want an LLM to generate. And as it turns out, structured generation is a hugely valuable thing that LLMs you can use with, it's a hugely valuable thing that you can coerce LLMs to do, because it allows you to coerce an LLM to generate type correct outputs. And you can insert all sorts of validators on a pydantic object to make sure that it is generating the output that you want correctly. So you can think about some of the potential downstream, right? One, you take completely unstructured textual information, you feed it into an LLM, and you ask it to produce a database entry. I've done that for protein sequences, where I've taken literature, and we'll ask it to extract a protein sequence, but also some of the properties that are described inside there as a secondary nested JSON with a few free-form fields, right? So those are all possibilities here. This is a very powerful pattern. And it's available in multiple LLM frameworks as well, like if you use Instructor, that is another very popular tool for doing structured generation. If you use, there's the folks out at, in France, I forgot what their name is, .txt. They are a startup out in France, and they have a very, very powerful structured generation engine that you can pay for. It is very, very cool. So I definitely encourage you all to check out some of what they're doing.
Isn't there outlines from them? I thought that was open source.
That's it. So Outlines is the open source version, and then they have some for very highly nested and highly complex data models that exist in healthcare.
Like Fire.
Yeah, exactly. Okay, so now that we've got that structured data model implemented, I would like you to go to the cell below and replace the answer, which is receipt data, with receipt data exercise, and that should work correctly as well. And if you would like to change things up and make things a little bit more fancy, you can actually feel free to change the data model yourself and see what it generates. So that's how we use that chunk of code here to instantiate a structured bot, and the structured bot in this case is going to be Gemma 3n. And so now let's put these bots to action. So the first error that you should see is you couldn't find the receipt_lunch.pdf file, right? There's a way out of that. If you go back to the GitHub repository, receipt_lunch.pdf exists. It is an actual receipt. Hit the download raw file button, let it download to your local machine, and then come to the Marimo file browser, click on that, and upload receipt.pdf, receipt_lunch.pdf. I have it in my LlamaBot repo already. So now it will show up over here, all right? It's been blocked by Chromium, whatever. Cool. Everybody got that?
No.
No? Yes? No?
I'm back just a little bit.
Yep.
In the, where we were defining the dummy receipt,
Dummy receipt?
I'm getting a validation error. Wondering if that's something I'm supposed to be getting. I don't know if that's
Can you
just
go back
something I did
to-
wrong.
Oh, scrolling up here.
Where you define dummy receipt, just so I can copy your syntax?
Yes, can do, not a problem. So make sure you are putting in correct data types. Just now, I had made amount a string, whereas actually it's supposed to be a float, and that is one possible error mode with structured generation, or like humans doing structured generations. You're gonna enter data with the wrong data type. Okay? Okay, so if you get past...
Where's that receipt file again? Sorry.
Yep, so if you come back to the LlamaBot repository /tutorials /PyData Boston 2025, receipt_lunch.pdf should be here, and it's you should be able to hit the download button, download raw file on the top right-hand corner of the, top right-hand corner over here. Everybody okay with that? So far so good? Yep, cool. Upload it over here, and then hit the play button. It should start cooking. Let's see. So first step is we convert PDF to images. The second step is over here, where we're gonna hit the Ollama API that I stood up, and I should expect to see a surge of requests coming in. Yep, people are coming in. Okay, that's good. And in the output that you see down below, you should see a bunch of logging, plus a bunch of just free text generation that is happening. That is what's happening over here. So basically, the thing that's happening right now is, first off, we convert the PDF into images just to make things compatible for vision language models. And then after that, for each image path, we have a prompt that says, extract all text from this image. Man, the connection's really wonky today. And then this line over here is where we actually call on the bot, right? The OCR bot is doing this step over here. And what we're passing in are two things, the prompt text and the image path, okay? So that's a little bit of a walkthrough of what's happening over here. And then the OCR response is going to be just this, message object that has a .content attribute. And so what we want to do is we want to put the OCR text inside a list so that we can use it later. How are we doing so far? Everything okay? People good? Okay. Let's scroll down a little bit more. What happens next is we take then the OCR text, we concatenate them into one long string, and then we pass that string into the receipt structuring bot, which is the structured bot that we had just created, which uses the pydantic model that everybody filled out. Okay? So far so good? And so if everything works out correctly, you should see this show up over there. Right? Now, if my memory serves me right, this LLM is not doing exactly the right thing. I think it should be 1444 in total, but unfortunately, it didn't catch every single thing. And so that is where we touch on a separate topic, which I will not go through today, but it's called evals. If you don't do evals for LLMs, you're doing LLM application writing wrong, okay? You must do evals, but I don't have enough time today to touch on evals. I will say you must do your evals, okay? Any questions thus far about what we've done?
So if we switch to another...
Sorry, let's do the mic for questions.
Just a quick question. If we switch to a different OCR model, the performance will be better, right?
Probably, yes. In my own testing, I've used GPT 4.1 and GPT 4.0, all no problems, 100% accuracy every single time I pass in a variety of image receipts. So, and actually, the only reason why I did this as a two-step thing is because for the open source models, the model DeepSeek OCR, it does not support structured outputs, so I need to do this intermediate step. Whereas on the other hand, if I go to GPT 4.0, 4.1, those models are vision language models that support structured outputs, so I could actually squash these two steps into one. And that's how I built it the first time around. I actually did it as a GPT 4.1 model that I was calling out to with a single step, and then I was like, well, I'm not going to get everybody at the tutorial to pony up their credit card to sign up for an OpenAI API key to then access GPT 4.1. So I needed to actually, for economic reasons, restructure the program as two separate bots. Okay, back there.
I just appreciate you choosing those two models because they can realistically run on new laptops.
Yeah, exactly. Back there as well.
Yeah, it's my, I'm running into bug here, which says, like, debug messages. When I extract the text, I get errors, processing message with role system.
Oof, okay. That sounds like a very tough to debug live kind of error.
No worries.
You could follow along with Ben, who's sitting right next to you. That would be probably really helpful. But we can talk afterwards.
I have that as well, but I didn't think it was a problem.
Sorry?
I have that as well, but it didn't work.
It seems to be working? Okay, all right. We'll deal with that later then. Okay. All right, everybody, let's move on.
Sorry, Eric, can I ask
yes,
a question?
more questions.
So,
Ian, let's do microphone.
I'm sorry. So when it ran through processing the receipt, I get like a markdown rendering of the content, but then the actual OCR response dot content, which is appended into the OCR texts, is a different thing.
Yeah, let me just think here. When you get so you may get back a simple bot, you will see the text get printed out at the
On the
standard
screen,
error
yeah.
in the screen. However, when it comes into a Python string, it's actually just like one long string. So one of the things you might be able to do, Ian, is to hit print that string, and it should look the same as what you're seeing in the console outputs. And if it doesn't, the other thing you could try is do MO. Marimo's already imported as MO.
Yeah, that's what I've done.
Mo.md.
That's what I've done.
And that will render as well.
I've already done those steps.
Okay,
but-
cool, sounds
okay,
good.
Thank you.
Well, then that's for the benefit of others. Thank you. Any other questions or comments? In the back, can we get the microphone to the back, please?
I'm sorry. I know you didn't mean to go over the evals, but in the scenario where there's like OCR related thing, how would you even evaluate it? Like, and like if the model like drifts or something, how would you like detect that?
Yeah. So So I took a course, paid a lot for it. So I'll share what I learned from that course. You have to look at your data. There's no way out. You have to look at the outputs. You have to look at the traces of your LLM program. The traces being defined as what was input, what were the tools that were called, and if there are any tools that were called, what were the outputs? Okay? So you have to look at that. That is defined as the data. There's no escaping. Yeah. And then there are situations, a subset of situations, where you can go and try to steer a secondary LLM as a judge to help you automate some of this, but you always have to be careful because there will be an error rate associated with that LLM. So you can never really escape fundamentally looking at your data. All right? Cool. Anything else? Over here.
This is not a theme of the talk, but wouldn't you be able to just directly read the PDF instead of convert it to an image and then do the OCR?
I think so. As I mentioned, there's always a bajillion ways to solve the same problem. That might end up being perhaps more token efficient if you do the PDF processing the right way. So for example, I could choose to, instead of passing the PDF through an OCR model, I could just pass it through regular OCR, like Tesseract, for example, and then do text extraction that way. Now, of course, I would have to check and eval, treat that as an LLM step, like an LLM step, and evaluate how good processing of that step was actually done. All right? Cool. Thanks a lot. Cool. Let's move on. I'm going to skip this blabbering about storing the structured data. Just know we're not dealing with that today, but you would want to have your access to your database access all set up in the legs. Sebastian.
I was just going to make a small comment on the bug that you had with the 1350 extracted. It's if you look at your system prompt, the amount says the total amount should be put there, and the receipt actually says total.
Okay, there we go.
So
okay.
That's why it's just taking you literally.
That's right. Okay, cool. That's one way that you would debug what's going on. You actually have to look at both the system prompt and the Python program itself. And so a lot of what I learned from building out just this tutorial set of agents as well was that a lot of the behavior of the LLM is steered through the system prompt. So if you can get a system prompt done really well, you can actually steer an LLM to do really powerful things, but you have to experiment. Okay, so I'm going to skip this section on storing the structured data. We're going to skip down to over here. I'm going to introduce you to this concept of a tool. Within LlamaBot, it's got its own little implementation that you can think about where a tool basically exposes a function, a Python function that I define as a tool, is capable of exposing what its docstring are, as well as what its docstring is, as like a description for an LLM, context for an LLM, as well as what arguments it accepts and the types of those arguments as well. And so this all becomes part of the LLM's ability to generate the right arguments. Now, what I've done here is essentially taken this LLM bot, or actually these two LLM bots, right? We have the bot that does OCR called inside this function, and we've got the receipt structuring bot also called inside this function. And so what we've done is we've basically said, you two bots, we know how we want you to behave. We know exactly the order of operations in which you need to behave. Now let me just wrap this up inside a function, put a bow tie on it, and say, I'm going to give this to another agent at another time, right? So that's all we're doing here. We're packaging up this workflow that we've defined in freestanding Python code, and now we're just putting it inside a Python function that can be treated as a tool for another agent bot, okay? That will come later. I'm not gonna go too deep into what these 3 decorators do, but they do help with what's going on. Any questions about, sorry, let me think here. Yeah, okay, so then if I were to try to do this one more time, man, like that 1350 became 1444. I wish money would just appear like that. So in any case, that is just me testing this function as well. So I do want to stop for a moment and ask if anybody had any questions thus far about the receipt processing side, and whether it's like sparked any other higher order thoughts.
If you need that 94 cents, man, I got you.
I would love the percentage differential. Ben back there. Let's pass the mic back, please. No, this is not Moderna where I can throw that mic around.
So you had the definitions, or we sort of gone over the definitions of agents and workflows before.
We did the definitions of agents and workflows before. But,
yeah. What would you call these like different components? Are they individual
that's
agents
a good question,
or
man.
yeah? Okay.
You know what? In this day and age, milk it. You know, just call everything an agent. No, I'm just joking. Workflows are things that feel a little bit more static qualitatively, and agents, I think, qualitatively feel a little bit more free form. You have a greater dynamic range of possibilities with an agent. With a workflow, it's kind of like, I know I'm supposed to upload a PDF, and I'm going to get back a database entry, right? Like that sort of thing. There's not very many ways that I can interact with that thing. And a workflow, another way that I think about it as a workflow is one which I can slap a UI on, and it's just a deterministic set of steps that have to be followed. Cool. Anything else? Okay, up front. One moment. Let's pass it.
I guess the non-science crowd's gonna lose me. So what do you call this thing we just made a couple of weeks ago? It sits in a lab, you scan the file to it, right? It has
it's a paper. I scan papers.
No, that's a build. I'm just trying to describe what we build and
yeah.
what you call it.
Yes,
It's a
yes,
workflow and engine.
Yes, sorry.
So it's a Gizmo sits in a lab. You put your like file next to it. It scans QR code on it.
Yep.
It asks you like parameters of it because you probably measured pH, you look the clarity and everything, and then it puts it in the limbs. Is it workflow or is it an agent?
I would argue that's more like a workflow.
It's a workflow.
Yeah,
but
and it has a human component where you're interacting, but the human's one way. There's no feedback to the human for a second turn.
There is, because it actually, if you said something wrong, or I mean, you can have conversation with it.
Oh, okay.
But very focused,
It's very focused.
Very constrained, yeah.
Yeah, that's where we're in the gray zone.
Okay.
Yeah. Yeah, I'm not exactly sure how I would define that.
Yeah, it's a premium.
It's a.
What is it? It's a workflow premium.
It's a workflow premium, maybe, right? Yeah. Semantics at that point. Yeah. Really, you know, like if you're in an org that isn't maybe as up to date, just milk it and like call everything an agent, man. Seriously. Like I built an agent. It's just a workflow, but it's an agent. You know. Yeah, that's what I would do. If you are in an org that's a little bit more savvy, I think people will start to want to have these definitions clear. And that's more a human problem than it is like really you're solving a business problem. That's the most important thing. Yeah. Cool. All right. Let's move on in the interest of time. I am going to skip the bot spans as well. That was something I was implementing last night within LlamaBot, so we don't have to go through that. It's not core to what we're doing here. We're going to actually do the exact same exercise for invoice data. So what we're going to do in both cases, it is text in, structured data out. Okay? However, in the first case, it's text of any arbitrary size that just happens to come to you. It's not really text that's coming from a human per se. Right? It could be a machine-generated text, and you just need to parse it out. The second one is an invoice writer. And really what we're trying to do here is say, I want to command an LLM to produce the invoice for me from natural language prompting. That's all. Right? And I can choose to give as much or as little information as I decide to. If I give not enough information, you'll see what happens. And if I give enough information, you'll also see what happens. You can experiment with that as it comes. So what I would like you to do now is to also help me implement invoice data exercise. So this is the second structure generation exercise that I'd like everybody to go through. So go ahead and implement the Pydantic model for yourself. And again, if you're not feeling it, just scroll to the bottom, copy and paste the answer, and come back up. That will also work. Which actually, in the interest of time, that is what I am going to do. But I am going to give people about 3 minutes, 4 minutes to finish whatever they can. So I just finished filling out all the fields. No expectation that you all did that. If you all just filled in, if you just filled in field plus the type, that's good enough. I did that to pace myself so that I didn't rush forward in the tutorial. If you could then take invoice data exercise as the Pydantic data model that needs to be generated and pass that into structured bot down below. All right. You should have a cell that's below that looks like this, where the key line, the only line that you need to change is Pydantic model equals invoice data exercise. Okay? So I just want to get a quick show of hands. How many of you have been able to make it to this point? Okay, cool. I'm going to wait a few more minutes for people to catch up. Yes, question about Marimo.
So as you're adding descriptions to each field, I wanted to catch up, so I copied it out of Marimo and into Claude and I did one of them and had it do the rest of them so that my screen looks very close to yours, but slightly AIified. Yep. Is there a way for me to get a VS Code AI editor inside of the notebook thing like Marimo?
Is. Marimo does have a pretty wide range of AI capabilities. If you run Marimo notebooks locally, you can add, you can do UVX, Marimo. Actually, I'm going to show people. I'll just show. Yeah. I think it's better if I just show than tell. GitHub, LlamaBot, okay. Tutorials, PyData Boston. So what I'm going to do here is I'm going to do new S LlamaBot. I'm going to do a TMUX session just so I can show things side by side, right? I'm going to do UVX Marimo edit, sandbox, a backoffice.py, but I'm going to add a few flags. Watch, MCP, and no token. That should work. And on the right-hand side, I'm going to start Claude. Okay, so that's running. I want you to edit backoffice.py by adding a new cell at the bottom that says, hello, Adam. So let me go to the bottom down here. It's going to do its thing. The watch flag is what makes the Marimo server continuously poll the file system for any new changes that are showing up on the file system. And so if Claude Code finishes, at the bottom down here, we will see hello Adam showing up. Yep. Okay?
It's different than I want. It's better than what I had.
Good question about it. Is there a way for the Claude to get back the results of notebook evaluation?
With MCP,
so there is MCP
you can, that is the MCP flag will allow you to will allow Claude Code to inspect notebook state.
So CLI, that works.
Via CLI, exactly. And I primarily code in Cursor, so on my personal projects and GitHub Copilot for work. And so I would add the Marimo MCP server on whatever it's running. The no token flag is important just to keep the URLs kind of clean, right? And so yes, so we've got that down there, and hello Adam has shown up right there.
Yeah.
So that's but one way to use AI with Marimo, right? If you do Command-Shift-E on your, or Control-Shift-E on your laptops, there's built-in capabilities, and also agents. Where are you? Right here. Chat and agents is also another option. If you have an API key out to OpenAI, Anthropic, Gemini, etc., you can use it in line here. I think one of the powerful things is you can actually add a particular variable or a function, and that gives context of that function to the coding agent.
I found if you choose Marimo models, they give you some free credits.
Is that right? Oh.
Go try it.
I didn't realize that. Okay.
Oh.
Maybe I don't have it here.
Doesn't show it.
We can try after. Yeah,
It
if you have it on your side. Yeah. Yeah. Cool. So I'm just gonna. So that's a few ways that you can interact with AI within Marimo. All right. Hit OK. So okay, cool. So let us now test drive the invoice writer bot. I'm going to ask you all to add a new cell below, and I want you to call on it and just and go like, help me write an invoice to to PyData for or NumFocus at I don't know what is it? It's 135 Some Street New York City, New York State, for $10,000. Jim's gonna be sweating if I actually do this. The organizers for $10,000 for services. No, you know what? We'll be kind. $1 nominal service for pro bono consulting services. All right. Let's see what happens. Okay, so it's going to start generating, and boom, our invoice should be generated, right? Do you all have you all tried that for yourself and seen that it works? Still typing it? Okay, go type your invoice to NumFocus.
Sorry, all
yes.
we had to change for the invoice data exercise was just add those
fields.
Yeah,
That's right.
Okay.
Add those fields.
Change the name of a class.
And change the name of the class as well, exactly. Because over here, thank you for the reminder, this line over here, you want to change it to invoice data exercise rather than just invoice data. But you know what? Like you can also choose to add more fields or like take out some fields if that's something that you want to play around with. All right? Cool? All good? So that's again, just to hammer home the point. If this were an actual application, you would have an API call out that says like, okay, or you bake it inside, you might perhaps bake it inside like a web app or something where you'll flash up the invoice, you'll get a confirmation, is this correct or not? If it's not, go back and edit. If it's correct, then it will save inside the database and also maybe automate an email out to your clients for whatever is going on, right? Sounds about right? So like that would be the thing that you would do, but we're skipping that, obviously, in this tutorial. Question back there from Ben.
What do you think is the reason it chose 2024 for this invoice?
Yes, it's because we didn't put any constraints, and we didn't also steer the LLM to generate the invoice with a particular set of dates. Now, if you look down below, there will be a system prompt elsewhere that actually constrains the issue date to be today, the date of generation, and the due date to be 30 days from issue date.
But it's 2025.
Exactly, but that wasn't part of the system prompt for this bot.
Oh.
But a later bot down below has that as the system prompt, all right? Cool. Let's
train, yeah.
Yes.
They probably trained that model in 24, and it's
Probably.
a lot of days of 24, and it just assumes like
That's
it's,
right.
yeah.
That's right. It's going to reflect the so-called average of your training data if you don't steer it in a particular direction. Okay. Any other questions so far? Okay. So let's get to the exciting part. We've got a generate invoice thing. Yes, actually, over here. Right down here is where I do add in additional constraints on the bot, where part of the business logic here is that the issue date must be today, and I actually put today's date, the due date must be the due date, and we actually calculate the due date, and then that is also steering the LLM. You don't have to do it this way, by the way. You can also get the LLM to output whatever, and then you just add in the date on your own. That also works perfectly fine, right? So, like I was saying, there's always a multitude of ways to solve the exact same problem. I've chosen the LLM-based way just to showcase a few ways that you can use LLMs, but so that you know it's actually not just generating strings, but you can actually generate other data types if you steer it the right way. However, just know that there are multiple ways of solving this exact same problem. Okay, cool. So just like before, we're going to wrap the generate invoice thing within a tool called write invoice. And what we're going to do finally, so if you continue scrolling down a little bit more, you'll see another example of another invoice that is generated over there. We're going to skip all of that in the interest of time and actually talk a little bit about the agent part. So let's zoom out a little bit. I know there's been a lot that we've talked about. There is the receipt workflow that we coded up. And we coded up, in particular, the data model, the data model for a receipt. Then we did the same for an invoice, where we have a data model for an invoice. And you think about it, you can actually start taking free text and templating documents and templating other, it's a very general class of problems that you can solve that way. How do we then bake in the interactivity pieces? No! All right, I'm going to have to rerun that entire notebook. That's fine. It's OK. So how do we bake in the interactivity then? This is where we come into this agent loop. Now, if you go to Sebastian's talk on tomorrow, he'll talk about the only 2 loops that you have to worry about as a developer of an LLM. And I'm not going to spoil your talk, because that's your talk. So go listen to his talk. Meanwhile, within LlamaBot, I've rewritten the agent harness 4 or 5 times, as my understanding evolves on it as well. And ultimately, it does come back down to I have an LLM that is making choices about what to do next autonomously, but it is being steered very heavily by how the system prompt works. And you'll see that I've actually collapsed the system prompt in the Marimo notebook because it is very, very long, very, very prescriptive. And turns out that's a common pattern that you'll see for the development of agents. All right, let me just hit play, let it run through all of that. And I'm going to go to the mini-map on the right-hand side if I can find it there. Let's scroll down to, I need to install that. Let me scroll back down to the coordinator agent. Come on. There we go. So one of the things that I wanted to do here was to be, oh man, there's a lot that's not going to work until LlamaBot is fully installed. One of the things that I wanted to do here was to showcase a little bit of showcase 2 patterns when working with building with agents. This one is going to be a little bit more of me demoing, but you can follow along pretty easily. The first is to look at this function called chat turn. It's down here, slightly obscured by the window right there. And so the way that it works is you have, when you're building a chatbot type of agent, you have to think in terms of chat turns. Like a human initiates a message, and then a bot responds. A human initiates a message, another message, and then the bot responds. And so there's this, this concept of a chat turn that you want to keep in mind. And so the way that with Marimo's chat UI functionality, what you'll end up doing is you'll end up taking the chat message, say for example, the latest chat message that was sent by the bot, by the human, and then passing that in. You end up passing that into, oh man, this is, you end up passing that into the LLM bot itself. And so if I were to come down here, and wow, I just have to wait for a moment for this to finish installing. Yes? No? Is it going? Is it done? Oh, it's done. Okay, amazing. Great. Thank you. Let's zoom back in. So one of the things that we've done here is with the code, I'm not going to go overly emphasize too much about it, but it does enable file upload capabilities. So for example, you could upload, for example, like a receipt for coffee, which is what I'm doing, and then do something with the chat turn pattern over here that allows you to actually interact with that bot with the file in memory, right? Like it's something that I've tried to enable or show a pattern for how this might work. And the way that it works here, you might say, for example, take one of the pre-baked prompts over here and go process the receipt file I uploaded using the file widget above, extract all the structured data from it, hit enter, and let's pray that it works, because this doesn't always work exactly the way you think you would want it to work. And this is something that I also wanted. So first off, two points while this is cooking in the background. Does this sound like the kind of prompt that a human would write? No, absolutely not. Absolutely not. This is placing this kind of prompt places a very high, like expecting this kind of prompt to come from a user, places a very high burden on the user for a chat agent, right? If we think about the savviness of users, not everybody is going to be savvy enough to know how to prompt an LLM to do very specific things, to be extremely precise and verbose. So that is going to be an issue. But I still have it. Why? Any guesses?
Workflow.
Workflow.
Building workflow.
Building workflow. Can you elaborate?
This looks more like a system prompt, and user would upload it to widget, and this would fire up anyway.
Yeah. Okay. You're getting there. Any other guesses? Okay, I'm going to reveal why. When you're in the early days of building out an agent, because it's a stochastic system, because there's so many moving parts, you actually want to have what I would call a perfect prompt handy that is fully prescriptive and has the entire set of behavior that you would expect to come from, that you would expect in an idealized world. And this helps you eliminate many, many sources of failure modes or variations in the earliest days of like building out the agent. So imagine if like every time I tested the agent, I had a variation of like, hey, and then process that, right? Like, how is that helpful for building out the agent? It's much more helpful if I have a very controlled suite of prompts. In my case, I'm only showing one per task that I expect the agent to do. I have this suite of perfect prompts that allow me to steer the agents in a very particular direction. And those represent the best of what an LLM should be able to do, and your expectation should be, in the wild, you're going to get really, really wacky inputs coming in. And this I saw live. The guy who's responsible for helping with AI adoption at Moderna, I built like this stats agent that like does, fitting of GLMs behind the scenes in memory. I can take in CSVs and like have it output plots and stuff. He walked in and he just went like, hey. I'm like, dude, is that how you talk with a statistician? No, right? But he is not even a laboratory scientist, so he's not tuned. But that's what will happen in the real world for any of your applications that you build, if you build it especially as a chat system that accepts natural language. So you might start to get a sense of my own preferences. I really don't advocate that you build chat systems. You should build more things that look more like workflows because they have very, very high value. But in the case where you do need to have chat orchestration happening, it is possible. And so let me peel back a little bit about how this got done. I need to come back up to here where we defined the agent bot. The agent bot is another bot within the LlamaBot family that accepts Python functions that have been decorated correctly. It accepts these functions as tools that it can call on, and it also comes with a suite of default tools like check today's date or respond to user, or because it's running in a Python runtime, you can actually return a Python object to user, right? So those are all possible things that can be done with the bot. And the model name that you have there is the so-called agentically trained model, the tool calling model that is capable of autonomously deciding based on the request and the system prompt, what tool should I call on next? And these tools, in addition to the default tools that are provided, are part of that toolkit, right? Now, if you were to use like LangGraph or other agentic, SDKs, it's the same concept as well, right? You would want to define tools either through MCP servers or by Python functions that are passed in. And just notice over here as well, write invoice and process receipt, those are LLM-enabled workflows. So bots can be tools for other bots, right? So there's nothing stopping you from adopting that design pattern. You do not have to have like this maximalist one big bot that does everything. You're allowed to have like, it's equivalent to the sub-agent design pattern, right? I thought I saw some hands. Okay, yes, Vlad.
I actually find the value for all the bots to respond to the hey. Like you just have a little in a system prompt because that's natural reaction for everybody.
Yep.
Because, and I noticed that's not only me, the Claude code. If I launch it, I always say hello. And what it does, it reads the Claude MD and all the like whatever commits. Like, it actually responds to hello. Like
yes, that is good, right? Like to be able to deal with the variety of like requests. And actually part of what you want, a design pattern that you may want to have here is that if you get a request that is out of bounds for what an agent is supposed to do, you actually have instructions to the bot how to steer the conversation back.
Yeah, and it's a little thing to add to it. So if you actually ever send the email before, right? So that SMTP protocol, the very first it sets to the other send server, it actually says hello.
Oh yeah, that's right. Yeah, that's right. I think we got one back there. Oh, did you have your hand? Yeah.
I was basically gonna say for a lot of like customer service bots that I think are already out there and probably use some sort of LLM, the chat windows don't always let you, type whatever. They have like predefined message blocks, and it seems like it's
Amazon
very much.
Amazon does that, and that's so irritating because I always want to just talk with a human.
And even on like the phone, but and if you do spam it, I don't know. My tactic is always just yell operator at it until I get to a human. It does not handle it.
That's right. Cool. Do you have something, Sebastian? No. Okay. Cool. Okay. One of the things that doesn't always show up, but if you try it for yourself, I'd like to invite you to try it out, is to come to the chat window and try either the first or the second prompt. Sometimes, but not always, so this is not a reliably, I have not yet figured out how to make this completely reliable, but if you remember, we had this rich HTML display. Marimo, I know it went blank. Marimo's chat UI has the ability to display rich HTML. So if we're lucky, oh, look at that. Boom. You can actually have like the rich HTML display show up. So that's pretty cool. I just wanted to make a quick plug for that. If you look at the architecture of what the agent bot is actually like, you can evaluate coordinator bot, and it will show you a Marimo diagram. Mermaid diagram within the Marimo UI of what tools are available to it. You'll notice we provided write invoice, process receipt, and list uploaded files. But above, there's also today's date, respond to user, return object to user, which was just called, so which is why we can return that HTML displayed object to user, as well as inspect globals, which allows me to look at what objects are available in Python memory right now. Those were tricks that took me like multiple weeks to figure out, even with AI assistance. It's not, you have to kind of do some kind of weird metaprogramming looking inside the exact runtime and then manipulating the runtime environment with Python as well. So it was pretty fun to try to code this up. I don't recommend anybody try that. Like, it'll be a security nightmare. Your cybersecurity folks will come hounding on you. So you end up just having to run everything inside a container. So that's just how it ends up being. Okay, cool stuff. How are folks doing? All right, so I'm gonna let's go down. I wanted to leave everybody, we're going to wrap up now, and then I'll leave some time for Q&A. But wanted to, my hope from this tutorial was that it demystifies how you go about building agents. Really, you'd want to pick an agent SDK. You don't have to use LlamaBot. You can use any agent SDK you want. But you do want to define what are the specific things that this agent can do, right? Like I build a stats agent, I'm not expecting it to do like receipt processing, for example. And likewise, if I build a receipt processing agent or a back office agent, for example, I'm not expecting it to do design of experiments and like critique of experiment designs for me. You want to define first what you expect your agent to do, and then give it the appropriate tools. And even those tools themselves can be LLM-enabled tools themselves, right? You don't have to, tools do not have to just be pure Python code. You can call out on anything that looks like an API, and if it's backed by another LLM, then so be it. It gets the job done. Another example, another thing that I'm hoping everybody took away from today was the utility of structured generation. We did like two examples of structured generation, one where we're generating the receipt with its particular schema, the other where we're generating an invoice with its particular schema. A lot of your applications where you work will be structured generation. I can guarantee you that, because where you need natural language input into a structured database, that's exactly where LLMs are going to find its value. Cool. And the final thing that I think I want to leave everyone with is that you can actually do, we did all of this with models that in theory can work on a laptop that has like 32 to 64 gigabytes of RAM. And if you're judicious about your model choice, you can actually bring it down to fit on laptops that have only 16 gigs of RAM. So I'd really encourage you all, like, go experiment with the variety of models that are out there. Also check out Ian's talk, because he's our tutorial, right? It's today? Yes, right after this, on how you can do local LLMs that fit on your local laptop, right? So with that, I'm going to end the tutorial here. I'd like to thank everybody for coming, and I'm also, maybe for the recording, if you'd like to have like a discussion, I'm happy to continue by mic, but if otherwise, feel free to go get some beverages, some refreshment and the likes, and enjoy the rest of the conference. Thanks a lot. Okay, so if you'd like to stay around for discussion, I'm happy to do so until 3 p.m.
Thanks, Harry.
Yeah, back there. I think we'll continue on record so that it's all on the recording.
Hey, Eric, great talk. Thank you. Just have a more general question on the framework. So you wrote LlamaBot, right? I'm just curious, like, what prompted you to do that as opposed to using like what's available, like LangChain or Llama Index? This sounds like a lot of work, and that's amazing.
Yeah. First off, don't use LlamaBot in prod, because that'll give a lot of pressure on me. No, but jokes aside, I don't understand something until I build it. So I built LlamaBot to help me understand the LLM ecosystem a little bit better. So you'll actually see that LlamaBot does have a lot of, it's like LLM capabilities. It's got a ragged frontier. It doesn't do everything that you might expect from a framework, but that's also reflective of like where I have done my exploration of LLM stuff. It also does some things that you don't find in other frameworks. Like, for example, runtime execution of Python code. I wrote that inside LlamaBot. So I actually can get an LLM to generate code within a Marimo notebook runtime and then run that code inside that same runtime, which is very dangerous. Don't do it. But if you do it, it does expose some really cool capabilities. Like I can get it to write GLM code live with the right syntax, and I don't have to template out the code. It just writes the code for itself, and then it returns an object, and then it actually manipulates the globals dictionary of Python to insert back the objects that were created into memory, and I have prompts inside that tool to help steer the LLM to do that. So a lot of LlamaBot was written to help me understand LLMs better. And if you use it for your hobbies, I'd be really honored. Like that'd be awesome. And if you do have, maybe more seriously, if you do have like ideas on how to make it better, I'd be open to listen as well. Yeah, that was the main reason why. Any other questions?
Yeah, so, I mean, as you've talked about wanting to develop this further, you also mentioned evaluation.
Yeah.
Have you built any evaluation capabilities into this yet? Or have you thought about even like LLM as a judge type of evaluation in a system like this where, you know, after I've created my invoice, there's something else that's cross-checking to make sure my invoice is right and I'm not missing 94 cents, right?
Yeah.
Something like that.
Yeah, that's a good one. So I took a course. That was very expensive. And what I learned about LM as a judge in that course actually was that it can be cast as a structured generation problem, where you have the inputs to the first bot and the output of the first bot as as joint inputs to the judge bot. And I think you have, if you do not have a Python function that you can write plus minus on whether on that criteria it was done correctly or not, then you can use an LM you can use structured bot to then do the evaluation. You would want to have, however, a powerful enough model for that. You kind of generally want to rely on more powerful models for LM as a judge until you've done the further legwork, like where it makes sense economically, you've done the further legwork to then evaluate the judge. So there's always the problem of who's going to evaluate the evaluator, right? Who's going to evaluate the judge? So and that's why when it comes to evals, ultimately there's no way to escape looking at the data. So then, and every LLM as a judge will have an error rate that you have to accept, which is why periodically you just have to keep looking at both the data that you're evaluating with the judge, as well as the judge output against ground truth to make sure it's correct. So then, how then do we look at that data? So then there's this notion of traces and where you want to put logging into the mix. There was this span, you may have noticed the spans code inside the notebook. That was all developed within the past 4 days. And it was me trying to figure out like what are the most ergonomic patterns for logging, and how do we keep track of very highly nested behavior, right? If you take a look at the tools that are out there, they're great ones. I didn't write this to replace those tools. I wrote it to understand them. Pydantic Logfire, I think, what is it, Langsmith or Langfuse?
Both.
Both of them? Okay, yeah, there's so many of them.
Favorite one.
At Moderna, one of my colleagues stood up Langfuse, so we use it. And I think it's, in my opinion, it is a what works kind of situation, and what works for the economics that you have at your company. Like we're too cheap to pay for software. In certain parts of the company, we're too cheap to pay for software. So we stand up open source stuff and we learn how to work with it. But in other places, that's not always the case.
Yeah, if you use Databricks or Datadog, I think they have their native trace products as well.
Yes, yes, exactly. All right, I think we got a question back there.
So we had this problem of we didn't provide a date for the invoice.
Yeah.
How can I teach the bot to tell me there is no invoice date, I can't create the invoice?
Yes, that's great. So if you tried to do the perfect prompt in the agent bot chat window, if you deleted the date, you might observe that the agent bot will come back and ask you for additional information. And that was actually put inside the system prompt for the agent bot. So I hid the system prompt for everybody because that thing was just like very, very, very long. But the system prompt really governs a lot of the behavior, right? Yeah. So if there's not enough information available, then you want to kind of rely on the system prompt. But then also at the same time, you might set up your Python program slightly differently, where instead of requesting an LLM to fill out the dates, you actually make them a required argument to the function, you make them a required argument that needs to be passed in by the user. So let's say we've moved away from a chat system and now we're inside like a form filling situation, right? You make that a field that needs to be filled in by a user, and if they don't fill it in, you just can't proceed, right? A required field. So there are multiple ways to solve that problem. I would avoid being chatbot maximalist, and I would also avoid being LLM maximalist. Try to solve as much as you can using traditional programming until you hit the point where it's like either the gains are so ergonomically good that you want to use an LLM, or there's absolutely no way that you can solve whatever problem you have with traditional programming, and you need to use an LLM.
A second question in the same direction. We missed 94 cents. Is there any way for the chatbot to come back with, I'm very sure about this is the right amount, or I think it's this amount, and you better check?
I do not trust model output uncertainty scores, so you have to look at your data. Like, people have suggested, yes, you can put a confidence, you can get the LLM to output a confidence score. That is folklore. Please do not do it. Right? Yeah.
Today, right? You're absolutely right.
Yeah. You're absolutely right. Yes. Cool. I think Sebastian. Yes.
Yes, more of a comment than a question, since we talked about structured generation.
Yes.
I think there's one thing that a lot of people are not necessarily aware of, which is that the order in which you put parameters into your Pydantic model actually matters. Because like for Python, it doesn't matter. Like you can put any order, you can query it, off it goes. For dictionaries, it doesn't matter. For JSON, it's fine. But LLMs generate stuff in sequence.
Yes.
So if you have a Pydantic model, for example, like in your first example with the receipt thing, if you generate the description first, like you ask for that one first, it's more detailed than the summary of the category, and then ask for the category, suddenly your accuracy for the category will go up.
Yes, yes.
So that's a cool trick that a lot of people miss. It's really hard to Google and to figure out that it works, but it's actually a thing, so I just wanted to point that out.
That's great. That's the kind of folk knowledge that doesn't get written down, so we need to have more of that kind of sharing.
The order in which you specify parameters in your Pydantic model matters, because LLMs generate basically text from top to bottom. They always just next token, next token, next token, next token, right? So whatever you ask to generate first will be generated first.
Yeah, the context value is not uniformly distributed.
That's right. That's right. That's right.
Yeah.
I've seen inconsistencies of that with your system prompting too.
Yeah.
So it does matter what order you put stuff in.
Yes.
It's the classic example of if you wanted to do a math problem and you just ask it to like, what's the answer? And it just puts the answer, it will just guess. But if you ask it to explain step by step, it will walk you through the steps and suddenly you get a much better, more accurate answer because it writes out the steps first and then it has less to guess.
Exactly. That very complex conditional probability turns out to be better steered by having more context being generated first. Anything else? All right, we're at 3 p.m. So thank you everybody for coming. Really enjoyed the presentation. Hopefully it's useful for you. Enjoy the rest of the conference.